All right, so now we're on to 8.2, which is planning local driving routes. So the first kind of concept is what is the best route? Drivers can avoid issues and hazards more effectively by planning a route before driving. Two issues that might affect drivers include traffic and driving conditions. So the following map here shows a section of Mississauga, and over here, the concept is you're going to visit a new friend for the first time, plan a driving route from Antigua Road to Callum Avenue, and then complete the table. So over here, if you're going from Antigua Road to Callum Avenue, what you could do is you could kind of transit around this way. There are obviously many other ways you could get there. You could go around and join up. You could go up here and join down. But we're kind of planning for the most direct route at the moment. So we're going to use this green line. All right, so the next part here is to fill in the directions. So let's just do directions in general. So first off, you're going to, if you are starting here, turn left. So turn left onto Antigua Road. And then once you're there, you're going to turn right onto Gareth Road. And then after Gareth Road, right at the end of it, you will turn left onto Louis Drive. And then finally, once you've passed over here, you will turn right onto Callum. And then, so this part here, I'll just fill in because we kind of did it already. So once you reach Gareth, once you reach Louis, and then Callum, and then here the last one is destination. There is an extra spot in case you chose to do a different route, so you'd have room to do it. And then the next part here you would use, and I'll just erase all my lines, but you would use your ruler to measure out what the distance here is, and then your distance here to get this distance, and then here. So I've measured this out on a piece of paper and then converted it. So here you have your 2 centimeters is 200 meters in this corner down here. So if you measure it all out, you'll get 100 meters, 200 meters, 150 meters, and 100 meters. And then, so if you're driving it, if you measured this up, it will be 0.55 kilometers. However, the distance on Google is 0.65, and that's just because it doesn't know which house you are on the map. So if you said 0.60, it'd be pretty accurate. I'll write this in English. And then so this is from measuring plus Google. So then it says compare your route to the one on Google Maps, and then to compare your calculated distance to the one on Google Maps as well. So I'll actually show you how you can kind of do a measured distance in a minute here. All right, so obviously this is not the same map. We're gonna just look around the Ottawa area here. I'll just pick a random spot because I just want to show you how you're supposed to kind of access this measure distance feature in case you didn't already know. So we can choose literally any spot. We'll just pick this random spot right here, and I'm gonna right click, and then if you go down here, it's measure distance. And then if you click anywhere else, it'll kind of show you the distance, and you can click and drag this as well around. So if I wanted to know the distance between Blackburn and this intersection here, it's 2 kilometers. Now that's not driving distance because you'd have to do the 2 kilometers there and then do the 1.5 kilometers here. But you can kind of measure distances this way. And for later projects, you can always zoom out and measure even further. All right, so Mohammed works part-time delivering automotive parts. He earns $12.75 an hour. The deliveries usually take 4 hours. So how much does he usually earn? We have $12.75 an hour times 4 hours is $51. Okay. The following map shows portions of St. Catherine. Mohammed leaves the warehouse on Berryman Avenue and delivers to each destination identified with an arrow and then returns to the warehouse. So here we want to plan an effective route for him to do this quickly. So he starts at the warehouse. On Berryman Avenue, which would be over here. And then we want to hit all these kind of spots. So the first thing I would say is that he's going to go this way and then get this spot. And then through here, get this one. And then probably the most effective would be to go down a Russell instead of all the way up and back down and hit this one here. And then he needs to make it back so he can travel down Caston Road. And then turn down George all the way to Welland. Welland would be faster because it's a larger road. And then so he can travel all the way down this way. Probably has a higher speed limit. And then come down here again. So that would be kind of the route that I would put for him. Great, so now we're going to estimate the distance driven. So to do that, you're going to measure with a ruler. So here at the top, we have that this is 2 centimeters to 200 meters, at least with the way I'm measuring. I am this time measuring on my screen. So here, if we start back down here, this distance is going to be 2.5 centimeters. And then we have to turn. So we'll measure the next stretch, which is going to be 3 centimeters. And then we'll kind of estimate from one end to the other. It's obviously not going to be curved, but that's going to be 7.5 centimeters. And then we'll continue straight on to get to here, this distance. And this is 6.5 centimeters. And then finally, we have 7.5 for this. We have 1.5 over here. And we have 2.5. Thankfully, these last ones are pretty long. So this one here is 9.5 centimeters. The long stretch on Welland is 16 centimeters. And the last stretch on Berryman is 5 centimeters. So what you would have to do is add all these distances up. So we start with 2.5 plus 3 plus 7.5 plus 6.5, our 7.5 again, our 1.5, 2.5, 9.5, lots of 0.5s, and then 16, and then 5. So all this added up together gives you 61.5 centimeters, and that we now need to convert into meters. So if each 2 centimeters was 200 meters, that stands to argue then that you have 1 centimeter is 100 meters. So this here is going to wind up being 6,150, which is in meters, which is going to give you 6.15 kilometers. All right, so now the next question is, in addition to his hourly wage, Mohammed receives 35 cents per kilometer. Calculate his vehicle allowance. So it's 35 cents for each kilometer. We're going to times it by the kilometers. So 6.15 kilometers times 35 gives you 215.25. And this is cents. So we want dollars maybe. So you'll be dividing that by 100 to give $2.15. And then so his total earnings for one day are going to be his pay that we had calculated over here, 51, plus the $2.15, which will give us $53.15. And that is the end of 8.2.